recording. There we go. So we're again just focusing on this review of radicals, and I'm going to go back maybe a little too far. Might be a little too simple right now, but we'll jump into some more challenging problems here very quickly. So the square root of 4. Do you guys remember what the square root of 4 actually is?
16.
Go the other direction. The square root of 4 is 2. If you square 4, you get 16. And they kind of sound the same, especially with a mask. So the square root of 4 is 2. And this might sound weird, but we need to understand why it's 2. So when you guys look at the number 4, the number 4 can be broken down into 2 times 2. And if we look at 2 times 2, a square root pulls out pairs. So as soon as you have a pair of 2's, it pulls one out and we lose the root. That's what square roots do. They look for 2 identical terms, 2 identical items. So here's another little example. So what's the square root of 9? That one's 3. And let's think about why. 9 is 3 times 3. Square roots look at pairs. As soon as it sees a pair, it pulls it out and says, you don't need the root anymore. Let's look at another one. Let's look at the square root of 25. Guys, what's the square root of 25?
5.
It's 5. So think about why. It is 5 times 5. Square root sees the pair, and out it comes. Okay, now I'm going to try to mess with your brain a little bit, because that's my job as a math teacher. This one's going to be a little weird. So inside the square root, I want you guys to write the letter A, so it's not actually going to be a base number. It's going to be letter A. And then I want you to write A to the second power. Now think about what A to the second power is. Isn't that A times A? So if we take the square root of A squared, we have a pair of A's. Out comes the A, and we walk away. So square roots can be applied not just on numbers, but also on variables. Now you guys might remember from back in the day in algebra, kind of depending on where you were before COVID occurred, you guys might remember there's very specific rules about fractions in roots and roots on the denominator or the bottom of a fraction. We're not going to focus so much on the fraction rules, and this is going to sound maybe a little selfish, a little rude. We don't need them right now in geometry. My pre-calc class is doing a lot with those, but for us in geometry, we're going to stick with some more simple things for the moment. When we need to get to the fraction rules, we'll get there, one step at a time. So I want to talk about another example. I'm going to mess with you guys a little bit. On this one, we're going to take a look at the square root of 50. Now, I often get a lot of people say, oh, it's 25, because it feels like we're kind of breaking things in half, that concept of pieces of 2, but it's not like that. Instead, here's what I'm going to suggest you guys do. And there's more than one way to think about this, but this is just an option. Forget it's got a root for a second. Can you think of any 2 numbers that multiply to make 50? Give me 2 numbers that make 50 when you multiply. 5 and 10. Was anyone thinking 2 and 25? It doesn't matter. And you guys get a choice right now. If you want to write down the 2 and the 25, or you want to write down the 5 and the 10, I don't care, pick one. Please don't pick 1 times 50 because that's not changing the appearance of the number. Okay, I'm going to focus on the 5 and the 10 for just a second. I'm going to wait for the airplane to pass. It's a loud one. So I'm going to look at the 5 and the 10. Then I'm going to go look at the 2 and the 25 in just a sec. So again, you only have to write down one of your 2 options. It doesn't matter which one. The 10 can break down. Give me 2 numbers that multiply to make 10.
5.
Thank you. 5 and 2. Don't say 1 and 10. Don't use the 1. It's not going to get us anywhere. So I'm going to rewrite this. I like to put the smaller numbers first. So we're saying that 50 is 2 times 5 times 5. And that is the case. 50 is 2 times 5 times 5. But do you guys remember what square roots do? Square roots pull out pairs. So this set of 5s, that's going to come out because there's a pair of them. But the 2 doesn't have a buddy. So it's going to sit inside the root, and we are going to walk away. This is called simplifying radicals or simplifying square roots. Now, if you wrote down the 2 and 25, don't worry. 25 is 5 times 5. We get the exact same thing in the root. We just started a different direction. And so out comes the 5, in stays the 2. It's the same thing either way. So this gives you some choices in how you break this down. What we're actually doing is we're breaking our value inside the root, this number, into what we call a prime factorization. Prime factorization. Prime means numbers won't break down any further, and factorization, we're getting all the values that multiply to make the original number. And you think about it, I can't break down 2. It's 2 times 1. That doesn't do anything. 2 is prime. I can't break down 5. It's 5 times 1. Doesn't do anything. 5 is prime. So here is a couple of different ways to use the same approach and get to the same answer. So I'm going to pause on this for just a second. Do we have any questions with the in-person people? Zoom people, if you guys have a question, you have to unmute because I can't see the chat right now. I'm going to show you guys another option, and I'm going to kind of put this on the side. This is totally optional. You could just go like this with your pen or pencil and say, I'm not writing it down, and just watch. Different brains think differently, and I think that's kind of the best thing about being human. Our brains are all different, and so I want to give your brain another option. If you're sitting here looking at this thing and I don't like it, well, here's another option. You're going to have to kind of choose between the two. So if you don't like either one of them, I'm really sorry, but get over it. But I'm going to start off with the square root of 50 again, and I'm going to break it down again into the 2 times the 5 times the 5, right? And I'm going to write it a little bit differently. I'm going to write it as 2 times 5 squared. Square roots and square powers, even powers, they undo each other. So the square root and that power of 2 brings the 5 out, and it leaves the 2 as a prime factor on the inside of the root. So some people, you guys learned this when you took algebra and pre-algebra, 8th grade math, all of that stuff. You learned it by writing out the exponent. I learned it by writing out all of the prime factors. If the exponent makes more sense in your brain, use it. If the prime factors make more sense in the brain, use it. You got to pick one. Because if you just grab a calculator and you're like, I'm going to outsmart her, I'm just going to type this, I'm not going to accept that answer. That's what we call an estimate. It's not an exact answer, because you see all those nasty decimals? You keep going. Calculator screen just got tired of showing them to you. I won't take 7.1 or 7.07. I won't take any of that. That's not exact. When I ask you guys to simplify a root, it's going to either be a perfect number coming out, like the square root of 4 is 2, or you're going to have some root mess left behind. No decimals. Exact values means no decimals. Okay. So let's go on to the next one. Let's take a look at, and these are just all a series of examples now, the square root of 75. Okay, I don't know what square root of 75 is. Can you guys give me 2 numbers that multiply to make 75? I know you can. If you have 75 cents, how many quarters do you have? 3. 75 is 3 times 25. That's where my brain goes. If I can think about money or food, I'm doing that first. Math comes later. Can we break down 25? 5 and 5. Okay, so I'm going to put it all back together. I have 3 times 5 times 5. We have a pair of 5s, so out comes a representative. Inside stays the 3. You could look at this and say, wait a minute. Square root of 25 is 5. That's 5 root 3. I'm okay with that. There's different ways to look at this. Questions so far? Okay, let's do another one. Square root of 80. I need 2 numbers that multiply to make 80. Yeah, I didn't notice it. So yes, I fixed it right. I could see it. Say that again? 20 and 4. Was anyone thinking an 8 and a 10? You could do that. 5 goes in a few times. I don't want to think that hard. If we do 20 and 4, if you do 2 and 40, it doesn't matter. Just jump in and find numbers. Okay, give me 2 numbers that multiply to make 20. 2 and 10. So I'm going to circle the 2 because the 2 is now prime. Can't go any further. But the 10, give me 2 numbers multiply to make 10. 2 and 5. The 2 and the 5, they're also prime. I can't break them down any further. So the 20 broke down, the 10 broke down, the 80 broke down. I think I need to come back up here and break down my 4 into a couple of 2s. We've got a little bit of a mess. So if it helps you in your organization, when you break down 80, draw a line through it and you know that it's gone. When you break down the 20, draw a line through it, you know it's gone. When you get to something that's prime, that you cannot factor or break down any further, circle it so your eyes know what to do. My eyes are looking at a ton of stuff. I've got 1, 2, 3, 4 2s and a 5. So remember that square roots look for perfect pairs. Well, there's a pair of 2s, and there's another pair of 2s, and then a 5 that doesn't have a partner. So out comes each pair of 2s with a representative. In stays the 5. All of this is with multiplication. So we'll take the 2s on the outside and turn them into 4, not because we added, but because we multiplied. And the 5 stays put. Questions? Let's do another one similar to this, and I'll actually move it so you can see it at the beginning. Let's do the square root of 180. Can you think of any 2 numbers that go nicely into 180? Or do you guys want me to be quiet and you try it? Let's do that. That's so hard for me. I'm going to be quiet. I'm going to let you guys try this. I'm going to come back and work through it with you. I'm going to step away and do attendance. So let's take a look at this square root of 180. Would someone help me out? How do you guys break down 180? Give me two numbers. You did 12 and 15. I never would have thought of those. What did anybody else choose? Say it again. 90 and 2. That could work. When I see a 0, I see a 10 times something. So my brain immediately sees 10 and 18. I'm intrigued by the 12 and the 15. I totally wouldn't have gone there, but I like it, so I'm going to go with it. Now, at this point, if you chose different numbers, it's going to look a little different, right? So the 180, go with that 12 and 15. I'm going to break the 2 into maybe 3, or excuse me, break the 12 into 3 and 4. So the 12's gone. 3's prime, I'm going to circle it. I'm going to break my 4 into a couple of 2's. 15 is 3 times 5, and those guys are prime. So I got a bit of a mess here. I've got a set of 2's. I have a set of 3's and a 5. So we're going to have some things come out, but some things not. Let's pull out a 2 and a 3, but the 5 stays. And so when we simplify this, this is the 6 square root 5. Questions on that? And so if you did a 2 and a 90, it'll look different, but at the end, all the numbers, all of those prime factors should come back together again. Questions? And it's totally okay to look at 180 and think, I don't know what goes into that. Start dividing. Grab a calculator and check it that way. Like, does 2 go in? Sweet, I got 2 and 90. You're looking at 90 thinking, I don't know. Start dividing and see what goes in nicely. It'll start to break out. This is actually like a tree diagram, kind of. So I'm going to scoot forward onto the next page. We're going to do a couple more examples. We're getting closer to being done. I'm guessing about 5 minutes. Taylor? Yes, absolutely. So the next example I want to do with you, let's look at the square root of 27. Okay, guys. Give me two numbers that go into 27. 9 and 3. Do you guys know the trick on knowing if 3 goes into a number? I don't know if anybody ever teaches this anymore because we're not supposed to teach tricks. We're supposed to teach understanding, but sometimes the trick can come in handy. If you add the digits of the number, 2 plus 7 makes 9. If 3 goes into the sum of the digits, 3 goes into the original number. Like 81. 8 plus 1 is 9. Does 3 go into 9? Yeah, 3 goes into 81. It's kind of a handy little thing. 243. 2 plus 4 is 6, plus 3 is 9. 3 goes into 9, 3 goes into 243. You guys ever learned that? That has made my life a lot faster because I deal with this stuff all the time. But you also have a calculator. Check and see if 3 goes in. So 3 goes into 27 9 times. 9 breaks to 3 times 3. So we have a triple set of 3's. Now this feels a little bit awkward. We're going to pull out a pair and we're going to leave a 3 behind inside the root because there wasn't another partner. We doing okay? So next example, this one's going to be a little bit different. I'm going to start throwing some letters at you. You're like, why? Because we can. So I want to take a look at the square root of a to the 5th. Now this isn't something that we're going to like start really splitting with multiplication. A to the 5th, if we go really old school on this, that means I'm going to write A 5 times with multiplication in between on my paper. That's what A to the 5th really is. But square roots look for partners. So out comes an A from this first pair. I'm going to look at the next pair, and if I can get my highlighter to work for me, out comes another A, and we have an A left inside. So when we look at this, this is where my students get tripped up. They're like, okay, I see a couple A's on the outside. Do I write that as 2A or A to the second power? Because these A's are multiplied to each other, this is A squared on the outside. You're playing with powers. Questions on that example? I'm going to do another one, and I'm going to tell you right now you're not going to like it. I'm just going to put it right out there. I want to look at the square root of A to the 50th power. Do you guys know why I say you're not going to like it? Are you going to really write out 50 A's on your paper? I'm not. I'm too lazy. And I know I'll miss one. I'm going to do that 50 times. Torture. It's dumb. Is there a different way that we can approach this? Yes. There most certainly is. Guys, when we're playing with square roots and exponents, what we can do is we can rewrite it, and this is going to be crazy talk right here. A square root is really cutting exponents in half. Crazy talk. Totally cutting them in half. So when you're playing with a variable with a power on it inside of a root, cut that power in half. 50 divided by 2, that's A to the 25th, and it's done. Now think about that. If I've got 50 letter A's on my paper, how many groups of 2 can I make? 25, right? That's why it's A to the 25th. Let me do a slightly smaller one with you. Let's do the square root of A to the 7th. I could handle writing 7 A's on my paper, but I don't want to right now. I'm going to write this as 7 divided by 2. But 7 divided by 2 is 3.5. And I said no decimals. Okay. How many times does 2 go into 7 nicely, like as a fraction, like doing a mixed number? Isn't it 3? Couldn't we rewrite this as A to the 3.5? The whole number is going to come out, A to the 3rd, and an A is going to be left inside. Why? Well, how many pairs of 2 can you pull out of 7 items? 1, 2, 3. How many are left? 1. So if you divide your exponent by 2, and you say, okay, 2 goes into 7 3 times. That's your power on the outside. If it's odd, you're welcome. You're going to have 1 left on the inside. So let's try another one. Let's do the square root of A to the 43. I am so not writing that out 43 stinking times. A to the 43. Okay. That is an odd exponent. Okay. So I know that I'm going to have A's on the outside and an A on the inside. Well, how many times does 2 go into 43 nicely? Goes in 21 times. That's how many A's are going to be on the outside. You can divide the exponent by 2. However many whole number times it goes in, outside power. If it's odd, you're going to have 1 on the inside. Here's another way to think about it. If we take the square root, oops, that's supposed to be an A, of A to the 43rd, we could write that as A to the 42 times A to the 1. Because 42 plus 1, that's 43. How many times does 2 go into 42? 21 with that little A left over. If you've got an odd exponent, pull one out and look at what's left and break them into pairs. I'm going to do one last example on this. Oh, I'm going to okay, one last example on this. Let's do 600 b to the third all inside of the root. So sometimes we're going to blend together numbers and variables. Okay, so it's kind of like two pieces in one. When I look at 600, I look at 6 times 100. When I look at 6, I think 2 times 3. 100 is 10 times 10. Or 50 times 2, absolutely. Then break down the 50, and you'll have 25 times 2. You just keep going. But eventually that 100 will give us a couple sets of 2s and a couple 5s. So all of this right now, I've got a 2, and a 2, a 3, and a couple 5s, and b to the third. So I'm going to pull out a pair of 2s. I'm going to pull out a pair of 5s. It leaves a 2 and a 3 and a b to the third inside. If I'm going too fast, somebody yell at me. Okay, let's clean this up a little bit more. 2 times 5 on the outside is 10. 2 times 3 on the inside is 6. And you're going to notice that I left some room between the 10 and the root. b to the third. Out comes a b, in stays a b. 2 goes into 3 once with 1 left over. You could look at it as b squared times b, out comes the pair. However you want to see it. There's like 3 different ways. Notice how I write it. If we have a number outside of the root and a variable outside of the root, they're written together with multiplication in front of the root. So it goes number, which we call a coefficient, variable, root, and then whatever's left inside. What questions do you guys have on this concept? Zoom people, if you've got a question, speak up. In-person people, any questions on that? And again, there's way more than one way to do these. Okay, so I'm going to stop my recording.